Okay, today we'll be looking at horizontal and vertical circle. Okay, a horizontal circle and a vertical circle. So I'd like you to follow me step by step. Okay, now look at here the motion of a body in a horizontal circle. If a body is tied by a weightless and inextensible string over the rigid support, okay, and moves in a horizontal circle, then the body is called a conical pendulum. So you can see that the circle here is this is where you hold it. Actually your hand holds here, then start making a circular movement down, just like a pendulum, but now making it, instead of moving it the way a pendulum normally moves, you move it in a circular form. So you're going to have a diagram like this. Okay, and I'd like you to note all the properties of the diagram because we're going to be saying some things about it. Okay, so from the diagram above, hmm, of a horizontal circle, T is the tension of the rope. So the rope is T, where you see T there on the diagram is the tension of the rope. R is the radius of the horizontal circle. So while you make the circle with the rope, okay, R is the radius, okay. And mg, of course, is the weight of the object that you are wheeling round. Okay. Then t sine theta, if you notice, t is at an angle. Look at t here is at an angle. Is at an angle. Okay. So when you check it, you see that the t has vertical component and horizontal component. The vertical component is t cos theta. The horizontal component is t sine theta, and that shouldn't surprise you, because if here is theta, here is also theta, because they are alternate angle. Okay, so t cos theta and t sine theta. Now let me remind you this: when you have a force at an angle and the angle is this way, theta, okay, the horizontal component is going to be t sine theta, but the vertical component is going to be t cos theta. Okay, horizontal component will be t sine theta, vertical component t cos theta. But if the angle is this way, the angle is touching the horizontal. In this case here, the first case, the angle is touching the vertical, but here the angle is touching the horizontal. It means that the horizontal component will be t cos theta, and while the vertical component, is going to be t sine theta. So please note that in case of resolution of forces. Okay, so let's rub the whole of this up as we continue. Okay, so you can now see that here the weight of the object and t cos theta counterbalances according to law of equilibrium. Okay, so hence t cos theta equal to mg. Then also t sine theta is equal to mv squared over r. Mv squared over r is actually centripetal force or centrifugal force. The centrifugal force always acts, this way. That thing that keeps a circle moving round, and it is equal to t sine theta. Now let's continue. If we divide both equations, where left hand side divide left hand side, you will see that t sine theta or cos theta, or let's see dividing equation 2, that's a mistake. It should be dividing equation 2 by equation 1. Dividing equation 2 by equation 1. So let me rub this off. You're going to have, so this should be dividing equation 2 by equation 1. You're going to have t sine theta, the left hand side now, all over t cos theta. I'm dealing with the left hand side. T cancels t. So sine theta divided by cos theta is going to give us what? Tan theta. Okay, so the left hand side is tan theta. Now the right hand side will be mv squared over r divided by mg. Okay, that means let me just put mg as a denominator here. So you see that m will cancel m. What are we left with? We are left with v squared all over rg, which is exactly what we have here. Okay, so whenever you have this pendulum, tan theta is equal to v squared all over rj. Don't forget that. Okay, so let's rub the whole of this up and continue. Okay, so we have still the conical pendulum. Also, let's look at the pendulum correctly. You are going to see that we have h. H is the vertical distance of the conical pendulum. L is the length of the wire or the length of the rope. Then R, of course, is the radius. Now, when you check the three, you see that they are right angle to each other. We can apply Pythagoras theorem. So that's why we have L squared equal to H squared plus R squared according to Pythagoras theorem. Now, but that's not the only thing we can observe there. We can also see that sine theta is R over L. That's opposite over hypotenuse. Let me rub this off. Sine theta is opposite. Opposite is R. All over hypotenuse is L, the length of the wire. Cos theta is H, which is adjacent all over L, the length of the wire. Okay, remember that L is length of the rope, sorry. H is height of the conical pendulum. R is radius of the circle. Okay, so please note this relationship. Okay, now, but if you remember, you see that T cos theta is equal to mg. T cos theta is equal to mg. And also cos theta is equal to h over L, like we've seen here. Cos theta is h over L. So if I substitute the value of cos theta in this equation, you see that T times h over L is mg. So from here we can find the tension of the rope. The tension of the rope is simply mgl all over h, in case you're asked for tension on the rope. So these are the things that we need to remember. The first is that to remember that tan theta is equal to v squared all over rg. Then now we should also remember that the tension T is equal to mgl over h. Not forgetting this, that L squared equal to h squared plus r squared, because we are going to use it as we continue. So let's move on. Now look at the question here. It says in a conical pendulum, a string of length 120 centimeter is fixed, okay, at a rigid support. The length of the string is 120 centimeter at a rigid support and carries a mass of 150 grams, okay, at its free end. If the mass is resolved in a horizontal circle of radius 0.2 meters, okay, around a vertical axis, calculate the tension in the string. Tension in the string, the best formula to use here is mgl, okay, all over h. Mgl over h. Let's check that. That's the formula here, mgl over h. Okay, so the problem, we have mass is given. Your m here from the question is equal to 150 gram, which of course we know to convert it is going to give us 0.5 kilogram. Okay, then we have g is acceleration due to gravity, which is 10, of course, or in this case we are asked to use 9.8 here. You use what is given. L is the length of the wire. The length of the wire is 120 centimeter, which is not so much of a problem, but we can divide by 100 to convert it to meters, so that will be 1.2 meters. Okay, so we can also the only challenge here is h, but we can find h because we know that we know that L squared is equal to h squared plus r squared. Don't forget that. So your L is 120 centimeter. So let me use the 1.2 squared equal to h squared plus your r here is 0.2. So we have 0.2 squared. 0.2 squared. Now, if we make the h squared the solid of formula, we are going to have that h squared will be 1.2 squared minus 0.2 0.2 squared. 0.2 squared. Okay. Now in that case, now if we use our calculator, let me use my calculator here to get that quickly. So 1.2 squared minus 0.2 minus 0.2 squared, I get 1.4. So I'm going to have h squared is equal to 1.4. Okay. And if h squared is 1.4, what is h? H will be square root of 1.4. Okay. And square root of 1.4 is going to give us 1.18. So that means my h here, I can use here. My h here is 1.18. 1.18. Okay, meters. This is beautiful. Okay, now that we found h, we can now substitute the value for t. That means my t now, which is mgl, let me make space available here. I can rub this off now. My t is mgl all over h. So in that case, I'm going to have my m is 1.5 kilogram according to that, then times g is 9.8, sorry, then multiply by your L is already 1.2, and everything is divided by h. We just got h to be 1.18. It's supposed to be a point, please. 1.18. So let's calculate this quickly. You're going to have 1.5 times 9.8 times 1.2 divided by 1.18 gives us the answer. The answer is 14.94. So we have 14.95 actually, 95 newtons. This is beautiful. This is beautiful. So this is how to answer questions like this. So let us move. I already have it written down, so but let's go through it together. Let me clean this up. I didn't remember it was typed already, so let's still go through it again. So let's see. So you see, your L is 120 centimeter, which is 1.2 meters. M 150 grams, which is 0.15 kilogram. Then R is 0.2 meters. Then you see that your L squared equal to h squared plus r squared. I've told you then. L is 1.2 squared, which is equal to h squared plus r squared is 0.2 squared. 1.2 squared is 1.44 equal to h squared. 0.2 squared is 0.04. Then collecting like term, you see that h squared is 1.4. And finally, you see that your h is 1.18. We've sorted that out. Now, if we now substitute T, tension is mgl over h. That's 0.5 times. I used 10 here, but 9.8. I didn't recognize that times 1.2 times 1 divided by 1.18. And you see the value for our tension, 1.53 newtons. This is beautiful. Okay, so let's see our next question here. It says a cord of 5.0 meters long is fixed at one end. To its other end is attached a weight. To its other end is attached a weight which describes a horizontal circle of radius 1.2 meters. Compute the speed of the weight, okay, in the particular part. Find the time period. Okay, we have two things here. We have to compute the speed of the weight in the circular part and also the time period. So solution, let's see. We have L to be equal to 5.0. That's the length of the wire from the question. R is 1.2 meters. So with that, we can find h. The Pythagoras theorem is going to be making h subject of formula will be square root of L squared minus R squared. That's what we have there, and we got 4.85 meters. Now remember, we said that tan theta is v squared over rg. Don't forget Don't forget that. But there is also something I would like us to note here. Okay, we are going to see that here. But remember, tan theta is also r over h. Tan theta is also r over h when you look at the conical pendulum. That's radius over height, opposite over adjacent. Okay. Now, if we equate them, you're going to see that r over h is equal to v squared all over rg. And if we substitute that, we're going to get r is 1.2 all over h, 4.85 equal to v squared over rg. Now, I would like to say something here. We can also make here like a formula. What do I mean like a formula? If you say r over h is equal to v squared over rg, if we cross multiply, we are going to get r squared g is equal to v squared h. Okay, so that means your v squared is supposed to be r squared g all over h. So that means your v is equal to square root of r squared g over h. So you can, if you remember that formula, r squared g all over h. Now, if you remember that formula, it's going to, help. So from today, you should just know that v is square root of r squared g, or gr squared all over h. That will go a long way. Or you can find square root of r squared, which is r. So you can finalize by saying your v is equal to r, then root g over h. So I would advise, this will go a long way. Instead of going through all the processes that we've gone through, know that v is r root g over h. Okay, let's cancel the whole of this. Note the formula, please, while we continue. Okay, so let's continue with what we've done. So you can see that v squared here will be, making v squared solid of formula, will be 1.2 times 1.2 times 10 divided by 4.85, and that will give us 2.97. And if we continue, v is square root of 2.97, and that will give us 1.72 meter per second. That's the value for v. Okay, but in the question we also asked to find they say find the time period. So I will do that quickly. The time period. What is period? Period, if you remember very well, we can get period from angular frequency. Remember that angular frequency is equal to 2 pi all over period. Even though we don't have angular frequency in this question, but we know that angular frequency is also v all over r. That means v, the speed, all over r. Okay, we shouldn't forget that. So equal to 2 pi all over period. Okay, so if we make substitutions here, your v is already 1.72, okay, divided by your r. The r here is 1.2, okay, equal to 2 pi. 2 times your pi is 3.14. Oh, sorry, your pi is 3.14 divided by t, period is what we're looking for. So remember that pi is 3.14. So if we cross multiply now, we're going to have that t is equal to 1.2 times 3 times 2 times 3.14 all divided by 1.72. Okay, so let's use our calculator here. We have 1.2 times 2 times 3.14 divided by 1.72. That's giving us 4.38. So that means the period in this question is 4.38 seconds. Okay, this is a beautiful one. Okay, so let's move to the next. Now here we're going to look at motion in a vertical circle. We are done with horizontal circle. Now in a vertical circle, the motion of the object being whirled around is not constant. The acceleration is not constant. In a vertical circle, you just hold what we do when you hold a rope, and swing it round, not in a conical form now, but swing it around. That's a vertical circle, just like you have in the diagram there. Okay, the acceleration of the body increases as it goes down the vertical circle and decreases when it goes up the vertical circle. This makes speed of the body change continually. So from here we can see that speed actually changes. The speed of the object here is not the same as the speed of the object here, not the same as the speed of the object here. That's at point A, point B, and point C. But you should note here that the speed is maximum at A, while it is minimum at B. So at A, the maximum speed is at A, but the minimum, the smallest speed, is at B. Okay? Now let's see this. So at A, the centripetal force at A is mv squared over r, of course. And mv squared over r is equal to T minus mg. T is the tension of the rope. Okay? You use the word TA because A is the one we are interested in. Is the tension minus mg. Just look at it here. Look at T. Look at mg. They are moving in opposite direction, so that's the reason for the minus. And the resultant force there is mv squared over r. That's the centripetal force, because centripetal force is what moves an object around the circle. So from here you can see a formula here that TA, making TA the tension solid of formula, it will be mv squared over r plus mg. If you like, you can still write it as you can factorize m, then open bracket v squared over r, then plus g. That's another way you can write that. Okay, that would be awesome. Now we also have at point B. In this case here, in point B, have you noticed that both the mg, both the weight and the tension are moving in the same direction? Okay, so in this case now we add mv squared over r is equal to mg plus t. Okay, so in this case my t now will be mv squared over r minus mg, which you can write as m into v squared over r minus g. Okay, that's the minimum tension. But at point C there is an angle. So you can see where we ended in point C here. TA is mv squared over r plus mg cos theta, mg cos theta. So theta, the angle theta will be involved. Okay, let's move on. Now look at the question here. It says an object of mass 0.5 kilogram attached to a string of length 0.5 meters is wheeled in a vertical circle. The circle at constant angular speed of 10 radians per second. Find the maximum tension and the minimum tension. Okay, let's see the solution here. Now first of all, we'll find the velocity. Velocity, since we are given angular speed, then the velocity of speed is omega r, which is 10 times radius 0.5. We have there 5 meters per second. Now the maximum tension T max is mv squared over r plus mg. So if you substitute the value there, you see that we get 30 newtons. Okay, substituting the value for mv squared all over r. V is 5, r is 0.5, then plus m is 0.5, g, we are using 10 as acceleration due to gravity. But the minimum here, you just subtract. You see, the difference is that in the first one, in the maximum tension you add, in the minimum tension you subtract, and we are here with 20 newtons. So that is beautiful. Let's see another question. Let's move on here. We have what we call banking of tracks. Banking of tracks. So let's see. Banking of roads is the phenomenon in which the edges are raised for curved roads above the inner edge to provide necessary centripetal force to the vehicle so that they take a safe turn. The angle at which the vehicle is inclined is defined as the banking angle. The inclination happens at the longitudinal and horizontal axis. Now observe the diagram here. You see that the road, if you are very observant, and if not, you can try that again. You can go anywhere you see a roundabout. or a curve where a car is supposed to move in a curved manner. Go and look at the road. The road is never straight. The road will be at an angle like this, and the reason is so that the car does not fall off. You know, it can maintain or it can gain necessary centripetal force to move round that roundabout or round that round road. So the angle to which the road is raised is what we call banking angle theta. Now consider a vehicle of mass m with moving speed v on the banked road with radius r. Let theta be the angle of banking with frictional force F acting between the road and the tires of the vehicle. Then the angle of banking theta is tan inverse of V squared over RG. Okay, we are not going into details, but that is the banking angle, tan inverse of V squared over RG. Another way you can put it, you can simply say it also means that tan theta is equal to V squared all over what? All over RG. Okay. So look at this question. A curve has a radius of 50 meters with a banking angle of 15 degrees. What would be the ideal or critical velocity for a car in this curve? Now let's see the solution here. Now remember we said that theta is equal to tan inverse of V squared over RG. It also means tan theta, I've said this, equal to V squared over RG. Okay, when tan inverse moves the other side of the equation, becomes tan theta equal to V squared over RG. So your theta is 15. If you substitute value, V is what we are looking for. All over R here is 50 meters. Then G is acceleration due to gravity, 10 is what we are using. So tan 15 is 0.25. V squared 50 times 10 is 500. So if we cross multiply, your V squared is equal to 0.278 times 500. That's giving us 139. So V will be square root of 139, which is 11.79. Okay, this is beautiful solution. Okay, so this is the last point for this topic. Thank you very much. Have a nice day.